This presentation covers wheels and axles. The important thing to note about wheels and axles are that they start off as a lever. In the case of the picture here on the screen, our fulcrum is here in the very middle of our axle. The purple, if we want to call that our effort force for now, the purple will go ahead and tell me that the axle is driving the wheel. That's going to have a mechanical advantage less than 1. Which would mean my blue arrow in this case would be my force of resistance. If I go ahead and say that the blue arrow here is going to be my force of effort, that means the wheel is driving the axle, which would mean my pink arrow here would be my force of resistance, and the mechanical advantage is greater than 1 for when the wheel drives the axle. Another item that's important to note here is talking about circumference when we're talking about wheels and axles. If I want to know the linear distance or the distance that a wheel would move over if it's gone through one full rotation, I'm going to just find my circumference. The circumference is the distance around a circle. In the case of a wheel, that's the distance around the wheel. Formulas for circumference are your pi times your diameter, or it's going to be 2 times our radius times the diameter. Radius is just half the width of a circle. Now that we have the basic understanding of a circle, let's go ahead and look at a quick example of ideal mechanical advantage. As with all of our other simple machines, ideal mechanical advantage deals with distances. It's our distance of effort over our distance of resistance. In the case of a wheel and axle, we talk about diameters. Here's your circumference formula again. So if they give me a radius on a circle or on the axle or the wheel, I have to find the diameter by multiplying by 2. They give me a diameter, like they did in this example. The diameter of the wheel is 20 inches, the diameter of the axle is 6 inches. When we look down at this part, this little section down here, it's asking what the IMA is if the wheel is driving the axle. So if the wheel is driving the axle, I know it's going to have an ideal mechanical advantage greater than, if the wheel's driving the axle, it's this one down here at the bottom, it is going to have a mechanical advantage greater than 1, meaning I'm putting in a little bit of force and getting out a lot more, but that's taken up in this greater distance. If the axle's driving the wheel, like it is on a car, you don't get nearly as much out of, you get less force out than what you're putting in. So it requires a lot of force to turn that axle. That's what this 0.3 is, or 3/10. So for every 3 pounds of, for every 3 inches, so I'm getting 3 inches out for every 10 inches of spin that I'm putting in, what we would consider the diameter. Now that we've done ideal mechanical advantage, we can move on to actual mechanical advantage. Actual mechanical advantage, just like before, deals with forces. So when we look at this example, we've actually got the forces put right onto the screen here. 200 pounds put onto the axle, 70 pounds put onto the wheel. If I want to know the actual mechanical advantage, if the wheel is driving the axle, once again, I know it's going to be a mechanical advantage greater than 1. In this case, we take 200, put it over our 70 pounds, and I get 2.86. If I want to know the efficiency, going back to our original formula, we have our actual mechanical advantage over our ideal mechanical advantage and multiply it by 100. So this system is going to be pretty efficient at 85.9%. What's important to remember with wheels and axles, as with all the other simple machines, you have to know what is supplying the force of resistance and what is supplying the force of effort. Force of effort, once again, is the energy or the force that I'm putting into a system. The resistance is what is being moved or what we're overcoming. So in the case of wheels and axles, if my wheel is driving the axle, the wheel is doing the work to move the axle. When the axle is driving the axle is the one doing the work to move the wheel around.